Hello, this is Clint Holstead, and this is an internet-based course called Introduction to Microprocessors. We are using a textbook called Designing Embedded Systems with PIC Microcontrollers, Principles and Applications by Tim Wilmshurst. So the assignment here for this was, before this lecture, the assignment was for the students to build this circuit with a PIC-DEM kit by Microchip, PIC-DEM Lab. So here's the kit. It has a solderless breadboard on it. It is called part number DM163045. DM163045, sold by Microchip. It has various components, LEDs, switches, and some various microprocessors. Now, I had to purchase the 1684A separately, but you can use any chip. You can use any DIP package processor that Microchip sells. That's the nice thing about this board. It comes with certain chips, but you can pretty much put whatever chip you want inside this into this solderless breadboard, and then there's a header pin that doesn't go anywhere, and you can just wire that the serial interface, the in-circuit serial programming, directly to the solderless breadboard, and basically have a platform to debug and evaluate any chip that Microchip sells. Okay, so I've got this wired up, but before I really show you how it works, I want to go over the schematic. So the idea of this schematic is it has two paddles. You can imagine these paddles being on the left of at the bottom and the top. So there could be a switch on the top, a switch on the bottom, and when you push the switch on the bottom, which I guess we could call it bottom switch here, and then maybe top. I actually can't remember which one is which. Actually this first LED RA3, that is on the bottom. That is true. That's the way it works. So you push the button here, the LEDs start to light successively. So this one lights, and then this one turns off, and then this one lights, and it goes off, and this one lights. So the lights go down the string, and then you have to push the top button, which is this button, as this last LED is lit. And if you do that, then the LEDs will go back towards the bottom button player, and then if that person presses the button right when this LED is lit, then it'll start to go back to the other player. So if you push the button at any other time, then you lose a point, and then you score A and B right there. So that's basically the way it works. I have everything wired up except for the score buttons. I just didn't wire that up. I guess I ran out of LEDs or something. But everything else I wired up. Don't forget to wire up the RC oscillator. You got the 10K resistor and the 100 picofarad capacitor. That goes from VCC to ground. Goes to VCC through the resistor to the capacitor, and then it goes to ground. Also notice that the book uses a 16LF84 part, but I'm using just the F part. The LF part is a 3-volt part, and the F part is a 5-volt part. So make sure you have, instead of 2 AA's here, make sure you have 3, because in the book it says use 2 AA's. You don't have to use a AA. You can use a power adapter. I'm actually using a power adapter that comes with doesn't really come with the board, but the PIC-DEM Lab kit comes with a power adapter socket, and so you can buy just a generic universal power adapter. That's what I bought to use. And also notice that the reset button is going, of course, to the PIC kit 3. It also goes, it's pulled up by this resistor. And you can always add a switch here to ground if you want to have a reset button. Also, after I program the part with the PIC kit 3, I do disconnect it, because if you don't, it's possible that program data and program clock can force RB7, RB6 low, which will keep the lights from lighting. So I just disconnect the PIC16. So after you get the circuit built, you can go to the website to download the code. It's www.embeddedknowhow.co.uk/book, and then all these characters. Once you go there, then you come to this website, Design Embedded Systems with PIC Microcontrollers, and then you can click on Appendix 2. It brings you to the code, program example A2.1. Then this is the code. Then you can just right click on it and then say Save Link As. That'll save it, and then you can save it to your directory. In my case, I've already saved it to this location right here, pingpong_84A. I put it in my MPLABX projects folder. Then after you do that, of course, you're going to have to create a new project. File New Project. You do a standalone project. Go to Next. And then you can go to mid-range, and then go to PIC16F 84A. There you go. Go to Next. We're going to be using the PIC16. So you click PIC16. We're going to use the assembly language, so you click MPASM. That gives you assembly language assembler. Project name, we can call it Pong project, I guess. Ping Pong project. And then you can just say finish. Okay. So once you do that, then you need to add your source file. So say add existing item, and then you just browse to where your file is at. Actually, let's copy the file over. I had it in this directory. Let's copy it. Let's paste it in our new project. It's called Ping Pong Project X. I'll just paste it in there. And then let's just do that again. Right click on source files, say add existing item, click on the assembly file, click select. It gives it to you right there. Okay. Let's see, let's close all this stuff out. Okay, so now if we open it up, there's a few things that need to be added to it, which is all this stuff here. When you get the file in, it's going to, I believe it's going to, it's not going to have all this stuff here. So what we need to do to get that is, that's the configuration bits for the oscillator and the watchdog timer. So in order to get that, I found a website that kind of describes what to do there. It's called www.sq-1.com/config.html. If you go there, then it gives you what you need to put there. So let's copy that. This is the configuration for the watchdog timer. So I'm going to copy all that. I'll just paste it in here. There we go. Let's line it up with everything else. Okay. Now we can go ahead and try to build it. And it says an error. And I think the error is you have to do the header file. You have to. Oh wait. Oh yeah. this is the wrong project. So let's see, up here you have to add, let's add the header file. Let's do add existing item, and then you have to go to your C drive. You have to find out where your MPLAB was installed. Hopefully you did the default. It'll put in C drive program files x86, and then you go to microchip, and then you go to MPLABX, and then you go to MPASM because that's the assembler folder. And then you got all these files here, so you just go through here and you pick PIC16F A4A, and then you select that. Now you have the header file for that loaded, and then yeah. Oh, let's see. File. Let's close the Ping Pong A project and file open project. Let's make sure you always have to make sure you have the right one open. So I think we called this one Ping Pong _ project, whereas my first one I had was called Ping Pong. So this one's called Ping Pong _ project. So let's open that one. Make sure we've got that one selected. Okay. We've got our config bit information in here. It's all nice and neat, right? Okay, so actually I'm going to do that again just to make sure. I think it actually grabbed the other one. So let's go back here. I'm just going to grab it straight from the website just to make sure that this actually information is right. Let's put it back in here. Put it back the way we had it. Confusing thing about MPLAB is sometimes you can't just start a new project. When you create a new project, it doesn't switch to that project. That's the weird thing about MPLABX. You would think when you create a new project, it would switch to that project, but it doesn't. So that keeps confusing me, but it'll probably confuse you too. So it's good that we just went over it. Now let's try to compile it. We should have everything in here that we need. Okay. Let's look at the errors. It says found directive in column 1. So let's kind of troubleshoot these errors. Click the first one. Okay. Oh, okay. Well, this stuff is not supposed to be in the first column, so it needs to be not in the first column. Okay, so let's tab it over. Okay, now let's save it. Okay, and then build it. Okay, now let's click here because this is our next error. You should always click your first error. What does the error say? Someone not previously defined. Underscore PWRTE. Oh, I think this is wrong here. That had a space there and it's not supposed to. Oh yeah, this code on this website, notice that there's a space there. That space does not belong there. Okay, so that is wrong. So it's good that we just caught it. So now let's save it. And now let's build it. Hopefully it's going to work this time. Yay, it works. So that's kind of the way you kind of troubleshoot some errors. You have to just click them in to see what's going on. Now it says loading complete. Now we can try to actually we can connect the PIC kit here to the board. Let's turn it off first. We'll turn it off, and notice that I have power here connecting here. If you don't do that, you're going to get an error that says could not detect target or something like that. You'll get an error that says cannot detect target, so we don't really want that error. So go ahead and connect it up. Be sure to power your board, and then turn on the board. And when you turn on this LED right here will light. Okay, so right there. Maybe I could use a better pointer here. This LED will light. Also, make sure you have jumper J4 installed. Jumper J4. It's right here. You can't see it on the screen, but just look on your board. It should be installed there. Also, one thing about this board that's kind of weird is the VSS power bus on the black power bus here on the sorterless breadboard is not connected to anything. The VSS. So you actually have to take a wire and you have to connect it to the ground on your pin, on your processor. Now, I did find out the VDD is connected to your power supply here, but the ground is not, and I have no idea why. But that is a source of confusion. Also, when you build this thing, make sure, a lot of times you have the sticky goopy stuff on the end of the resistors. You have to make sure to get that off, maybe cut it off. I think that's what I did, is I just cut the tips of the resistors off. Another thing is, I noticed that I use these wires here. You cannot plug a small resistor directly into the black power bus bar. You have to plug a thick wire from the black bar into the white board. So just use a thick wire. Don't try to plug your components, like your resistors and your LEDs, directly into the black bus bar, because the bus bar it's not going to grip those components well enough, because the component leads are usually really thin, whereas the wires are thicker, and so we need those thicker wires. Okay, so let's go back to the MPLAB. Now we're just going to click this button. It's going to say Make and Program Device. So let's click that. As we're doing that, costing, make sure your device is a 5-volt device. Okay, I'm just going to click OK there. Notice that when it's programming, well, let's see, is it done? Oh, it says programming, verify complete, so it's already done. I guess what I was going to show you is that when it's programming, some of these LEDs flash. That's because this PIC kit is actually changing the data on some of these pins. So they're going to change. But now what we want to do is we want to disconnect the PIC kit from the board. Okay, just disconnect it like that. Now the PIC kit will not be forcing the board to any values on any of the ports, which we definitely don't want that to happen. And so now, one thing you can do to verify that your watchdog timer stuff is really set correct, you want to make sure your watchdog timer is off. We kind of messed up here. We don't want to have the XT oscillator. It's kind of good that I messed up, because it'll show you guys how sometimes things get messed up. What we want is the RC oscillator. Okay, so we don't want that. So let's go to the header file. The way you do that is you go to the header file, you double click on this header file, and then you go down to the very bottom, and we want to grab the let's see, RC oscillator. So just say copy the RC oscillator thing, and they're going to paste it right here. And so let's go paste RC oscillator. So let's hit save. Now we're going to have to rebuild it again. Load completed. Okay, so now we can program. Oh, oops, I don't have my PIC kit connected. So let's just cancel that. So let's go ahead and connect the PIC kit back, because I can't program it without it being connected. So now we're going to say program, and then OK. Okay. Oh, I guess I didn't have it. Let's try that again. Let's look at that. programming verify complete. Okay, so it says on the bottom. I don't know what this warning right there is, if that's a warning or what that is, but yeah, it says verify complete. So it's been programmed. One way you can verify that the configuration bits are correct is you go to Window and then pick memory values and then config bits. And the config bits tell you right here that it's RC oscillator and watchdog timer disabled. So that's how we know RC bits are correct. Also, you can go to Window, pick hit memory views, program memory, and you can actually see what's in the program memory. You can see there's data in here, because if there's nothing in there, then it should be all zeros. But you can see there's code in there. Okay, that's program code. That's just good. It says go to 10, so that's the first thing it does. Go to 10 and starts executing. Everything looks good from that perspective. So now let's move this out of the way. And okay, now let's test it. Let's see if it works. So let's disconnect the PIC kit, and then we're going to just try and see if it works. We're going to push the button. Okay, it seems to work. This LED here, this one, the green one, tells you that you're out of play, so you're not really playing the ball. As soon as I press this, it's going to go the other end. Now let me see if I can play the game actually. Press it, press it, press it, press it. Okay. Looks like I pressed it too soon, and so it stopped. So that's pretty much the way it works. I can start this end. Oh, well, anyway, you get the idea. So I think that's about it. I can't really think of anything else that's important to know at this point. So just go ahead and give it a try, and hope you have some good luck. Thank you very much.